Constraints are essentially a way to control an object or a bone property like location, rotation, or scale through either itself, through another object, or even a bone. Now, constraints are awesome because they allow you to add sophistication and complexity to your rig, automating tasks that would otherwise be very difficult and tedious to animate. Now, there's a lot of constraints, and because of that, I've divided the constraint theory into 3 videos to make it easier to digest. So in this first part of the constraint videos, we're going to cover the longest one. All right, so it's the transform types of constraint, because there's 4 types of constraints. There's the motion trackings, which we're not going to cover at all because it's related to camera tracking, object tracking, as well as object solvers. So you can actually put real footage or 3D objects in real footage and track some of the stuff and all that stuff. So yeah, so a little bit of information for you there in the file. And there's also one of the transform constraint that we won't actually look at, and it's the transform cache, because it's related to Alembic as well as loading external cached file to objects, and we're not actually doing that here. All right, so in this one, we're going to focus on the transform constraint, which I have mistakenly misspelled here, but in the file that you have, it's fixed. It's transforms instead of transform. All right, so first of all, what is a constraint and where do you go to add that? Now, there's constraints for objects, which are the same, and there's constraints for armatures, which are the same again, but they're not at the same place. For example, we have a monkey head here. So you'll see that we have this little icon right here, which is the objects constraint. And this one has an action constraint, which we're going to view in the next video. All right, so, and here we have an armature. And for an armature, we also have object constraints. But if we do want it to affect the bone and not the armature itself, we need to go to the bone constraint tab. So you see it's the same icon, but there's a bone through instead. All right, so that's where we add the actual bone constraint. And to add a constraint that it is for bone or object, you have the little menu on top where you have, again, the motion tracking, transform tracking in relationship type constraint. Now let's add a copy location for this one. And the way to do it, you can use the picker. And in this case, I want to choose the A constraint, which is one of the 2 armature that is in the scene, this one. And for that, we have to specify a bone, and there's no pickers for the bone, so you have to know the name of the bone. In this case, if you click on the bone, you'll see the name right here. So it's bone 017, so bone.017. So let's go ahead and input that in there. So bone.017. All right, you see that right now, since it's set to world space, it will automatically snap to that place because it's copying the location based on the world space. Now, if you want to change that and have it change it or copy the transform from its position, you have to set it to local space on both sides. So you want to take the local space of that bone and transfer it to the local space of this bone. So that way I could put this bone anywhere I want, and it should affect it. All right. But when you have a constraint like that, it affects it in an influence way. So if you want to be able to move it a little bit, you need to toggle off a little bit the influence so you can sort of blend between the 2 of them. And you can also add drivers to that. You can control these with, custom properties and stuff like that. All right. So now I'm going to put it at 1. And if I grab this one and move it, you'll see that it actually duplicates the motion of this bone. So the location. Now, it does not do any of the other ones because it's a copy location only. All right. What is really neat with it is that you can also invert them and get some pretty interesting motion, right? And then you can also restrict it to only one axis if you want, like the Z axis. So you could get a motion like this. A good example of the actual location constraint inverted is an actual sliding door. You only need to animate one and it automatically animates the other one for you. And so it's really up to what you want to do, but now you know what this one does. All right, so let's take a look at the copy rotation. Well, like the title imply, it copies the rotation of a bone. All right, so in this case, we have copy rotation of this bone, and we're copying all the transform of that bone. Now you can specify one axis only if you want, like the y-axis. So if I move this, it will only spin the y-axis. You can alternatively invert these, right, to get some interesting motion. All right, so if I go move this one, now it's inverted. Cool. All right, so you also have a few mix type. You can add, replace. In the case of add, it will be additive to the, for example, if you give it a rotation already, which it's locked right now because I've locked it for this scene. So now if I have it set to add and I do this, it will add it to the actual rotation. If I choose replace, it will try to replace it. All right, and it sort of fails a little bit to do so. So it's always best to actually copy properly from one local space to another. So I usually use the add type or replace type. You can use after or original or offset. Play with those, we'll see what they do. All right, so let's take a look at the copy scale, which is the same thing. So you're basically copying the scale. Boom. You can specify only one, and you can even multiply the effect. So if you wanted to take more effect, well, you can. All right, so that's one way to do it. All right. Now you can also just use one axis if you want to. Now the copy transform will actually copy all the transform, that it is scale or moving and so on and so forth. All right, so, but you do not have access to select which one. So you cannot say, well, I just want the Y or the X or the, and so on and so forth. That's why you have these ones. All right, so the copy transform is if you really want to copy everything about it. All right, again, you can easily make it influence less if you would want it to affect a little bit less. All right, so it's really arbitrary and based on what you need to do. The limit distance is something else. It's different altogether. It's to limit the distance at which a bone can actually travel. All right, so I have it set to a distance of 2.5, and the object that it's referencing is this cube right here. All right, so because of that, it limits the distance I can actually travel with this bone. So all I did is I specified the mesh here and entered an actual distance. Now you have a few things that you can use. All right, like inside or outside. So it won't be able to go inside closer than that specified distance. Right? Or you also have on surface, which tries to mimic sort of like shrink wrap. Right? So inside is the coolest one, and you can also specify the distance. It's not actually using the actual object, but rather its pivot point, or its intensity in space, or its dot where it's originating from. And so from there, it's using that distance to say, well, you cannot go further than that. So really useful for certain things. So I'm going to put that back to 2.5. To clarify, it's basically using the pivot point of an object and it's constraining the object either outside, inside, or on the surface of an invisible sphere that is centered on the center of the object. So the object itself, or the shape of the object, really has nothing to do with it. It's really just to limit the distance at which it can travel. All right, so we have the limit location, which does what it implies. It limits the location. So in this case, I use the Z limit and I've locked everything except the Z. And I set it to -5 and 5. So it's going from -5 to 5. So perfect for sliders and stuff like that. Limit rotation does alternatively the same thing. So you can limit the rotation, in this case, -45 and 45 of the rotation. So really useful if you need to make a limit on something that turns and it cannot go further than this way. All right, so you also have limit scale, which again, you can do on each actual axis, or if you want, you can put them all, it's really up to you. All right, and then we have the maintain volume, which is really cool. All right, so this one sort of mimics like a volume, like a ball. If you squash and stretch a ball, or in this case of a cube, it's the same thing. All right, but you can also specify which axis it's actually affecting the most. Right, and you can even amplify that volume. So if I would want more volume, I can. All right, so very interesting. The maintain volume constraint is very useful for things that are squishy and squashy, like the rubber ducky here. So if I press S to scale, it will only scale with the maintain volume in the Z-axis, which is really cool. And then we have the transformation, which is a lot more complex. So what this one does is it takes the information of a source bone, which is this bone here. So in this case, it's that one. All right, so it's sourcing the local. So this one is parented to that one. So when I rotate like this, the object itself moves in space, all right, just like that. So it's moving in the X direction and coming back in the positive, negative, positive, negative, positive. So because of that bone, right? So that bone is parented to that one, and this one is actually copying and applying to the Z-axis. So it's replacing the movement there. Right, so very, very powerful. And you can specify if it's a rotation or if it's a scale. Now this one is very complex, so I suggest you fiddle with it a little bit. You can even change the mapping of the X versus Y versus Z. So yeah, fiddle with that one a little bit. I rarely use this unless I need something that has a complex motion, just like the example here. And something that you rarely see and will rarely need, but sometimes it is very useful. All right, and like I said earlier, I won't go over the transform cache because it's Alembic related. So in the next video, we're going to take a look at the tracking and relationship constraint.